Alright guys, you're welcome to my channel. I would like to briefly introduce us to functions in SML. So today our main focus is we're going to look at functions in programming language, and the programming language that we'll be considering is SML, which stands for Simple Meta Language. Uh, Now, we look at what are functions, we look at anonymous functions, we look at one-off functions, and we look at the temporary variable IT. Now, so let's quickly look at uh, the slides manual that will use as a guide. Now, if you can see this, you will I believe you have SML installed on your system already. So I'm going to start SML on my system. If you have SML installed, you just type SML, and that's that SML interpreter. Now, if you look at what we have here, you will see that this is just a variable. Okay, in SML, val is used to define a variable. So this is saying that I is a variable and the value of that variable is 3, and this is the end of that program. So if we are running this now, we just say val and say I equals to 3, and you will see that after my semicolon, the SML interpreter gives me an output. Now what this is saying is that this program has been interpreted by the SML interpreter, and it's giving me a report that I is an identifier, okay, which has a value of 3, and the data type of I is int. Alright, so the data type of I is 3. If I say val j equals to 3.0, you will discover that this changes to a real, that the data type of j is real. Alright, so now let's look at functions. Now functions is it takes input, does something with that input, and gives us an output. So basically that is the definition of function. Like in this case now, this function, which is defined by the keyword fn, takes x, does something with x, in this case add 1 to x, and gives us the result. So now this is the function. Okay, now this function is being stored in a variable called inc. Now, to be able to refer to this function, we need this variable. So let's see that in our program. So if I run this and I say here, I say okay, val inc is equal to fn, so put a space and an x, and I have this is x plus 1. So what you have here is a program, and that's the end of the program, and you can see the result. So what this is saying here is that a variable called inc is a function. As I say, it's a function which takes an int and returns an int. That is, it takes a data type of int and returns an int. Alright, so if I want to use this function now, if I want to use the function, I'll call inc, alright, and supply it with what? A value and semicolon. So I'm using the function now. You can see that this function as what? Taking a value 1, and what did he do with it? He took that one, added it to another one, and gave me a 2. Alright, now now because SML is has a feature of type checking, if I say ink and I put 1.0, I'm going to have run into a problem, because here this 1.0 has violated the definition of my function. The definition of my function is that my function, after this semicolon, you see the definition of that function, that the function takes int and returns int. But here I have supplied that function with a real, and so we're going to see that the SML is going to get angry at us. So let's run that for us to see it. Okay, so we see the problem there, that see the problem. Let's see it again. So see the problem there, that the SML has complained that standard input error, operator and operand don't agree. So what this is simply saying, that the operator domain is int, okay, but the operand that I've given it is real, is of data type real. So SML is data performs data type checking. So that's the point I'm trying to make there. So that's number 1 point. Another important point is you can use up arrow to go back to the function. Now you will see in our function definition, this is my program. In my function definition, this function f and x, this is the part that is we're writing. So this function takes x and add 1 to that x and give us the result. Now this is what we need, but without this variable declaration with val inc, there is no way that this function can be usable. Okay, and that's what I mentioned before. So an anonymous function is a function without a name or without a reference, that is a function that is not stored. So if you look at this function, let me write another one. Let me just run this, write another function. So if I say fn and I say takes x, and I say what does it do with the x, it has the x plus 2.0, and I press enter. Now this function cannot be used. I can't use this function again. There's no way I can refer to this function again. Alright, so that is why we use this part to be able to reference that function so that we can reuse it. Now another important point you should use is that SML has a way of storing the last run program in memory in a temporary variable called it. So if I call for it and I do this, it will give me the function definition, okay, the last that was run. But I'm going to try to do something here. Can I say it4 and see what it gives me? So that gives me an error. Okay, no, I think I should have something because it's real. That gives me a correct value. Okay, now I hope you understand what I'm trying to say here, that the last defined program that is running in my SML, in my computer memory, is this anonymous function defined here. But SML has a way of temporarily storing that last program in a temporary buffer, even though it doesn't have a reference, but it has a temporary variable called it, and I can use that it and supply it with this argument 4.0. So this 4.0 replaces x here, and now 4.0 plus 2.0, which is 6.0. The reason why we had an error here is that this 4 is what? is an int. So SML is an int, and this is an operation or operation mismatch. It's expecting a real, but I've supplied it with an int. So SML is strictly type checking. It checks the data type and make sure it is what it is expecting before it actually runs the program. Now, what I'm trying to say that for how long can I begin to use this? If I defined a variable val, if I just say 5 and I press this, okay, you will see that this 5 is anonymous variable. It's not stored anywhere. So you look at this, IT has become 5. So if I say IT 4.0 again, I'm going to run into trouble because IT is no longer referring to this one. It's no longer referring to this. IT is now referring to this one. I hope you understand, which is of type int. So this is just a variable. So IT is no longer a function. It has become what? Just a variable. Okay, because it's just temporarily storing this. So if I want to see this last one, I'll just say IT and it will just give me 5 now. So anonymous functions are used one-off. Okay, the functions, they are not stored. So the usefulness is that one-off function that you can just use once, and that's the end of their lifetime. All right, so if you want to reuse anonymous function again, you have to what? You have to redefine it again. Okay, but if you want to reuse it, is that you store it in a memory, in a variable location, so that you can refer to it as many times as possible. Now, one final thing I want us to take note here is if I define a function inc, say inc2, and I say it's equals to fn, and it takes x, and it returns x plus 1.0. You will see here that this is going to give me something different from what we have now. From this place, the SML interpreter is going to try to determine the data type of the function based on the operation that is being carried out and based on the available information that it has. Now, if you look here, this is I'm doing an addition with a real. So a real data type 1.0 is a real data type. So SML considers it. If you are not sure that 1.0 is a real data type, you can just type 1.0. It will give you the data type. So you see that this is a real data type. Now, if I declare that val int2 and I say it's anonymous function is equal to x, and I say x plus 1.0, so SML is going to determine the data type of this function based on any available data type that it has here, which is 1.0, which is a real. So because of this 1.0, which is a real, SML will automatically expect this to be a real, this input to be a real, and the output to also be of data type real. So if you run this program, you're going to see SML expect this to be a real and to also return a real. If you change the program and you change this to 1, let's refer the variable to inc3. So SML, as you can guess right, is going to change the data type to be an int, okay, and it returns an int. So that's a brief introduction of functions in SML. In subsequent modules, we shall see more about this. Please do give us a comment about what you think. If you like the tutorial, the video, please let us give us a like. If you don't like it, please give us a dislike. All this help us to be able to make improvement in subsequent um, presentation. Thank you very much.